Okay, today we're going to learn how to do conjoint analysis on SAS. I know there are different types of conjoint analysis, but for this example, I'm going to go through a full profile conjoint analysis. So let's look at how we can do this on SAS. Okay, so the first part, I'm going to make a two-level full profile conjoint analysis, meaning that there is only one or two levels for each of the attributes. So for example, I'm going to look at some preferences for automobiles. For make attribute, there's going to be two levels, that is domestic, 0. For foreign, it's going to be 1. For miles per gallon, it's going to be 22 miles per gallon, 0. 28 would be 1. Doors, 2 doors is 0. 4 doors is 1. And price, there are two price points, 22,000 and 18,000. Okay. So, as you know that the full profile conjoint analysis uses the rating as the dependent variable. So I'm going to input my data here. So for a particularly given attribute, the consumers are going to give the rating of the preference. Okay, so in this case, for the attribute 000, which means that it's a domestic car that has 22 miles per gallon, that has a two-door, that is 22,000, that preference score is 4. Okay, and we go on to the next one. Now the only difference change is that now you have the price going down to 18,000. Now the preference score is 41. Okay, and so on, and for all the full combinations that you could get. So I'm going to read in the data part here. Okay, so I'm just going to read in and select run. Now there are two ways to do this on conjoint analysis. You can use the regular regression, that is the procreg, or you can use the transreg method. Okay, so for a two-level conjoint regression, actually you get the same results. So I'm going to just run this both. Again, see what happens. Okay, the SAS is running. Okay, now I get the outputs. Okay, now this is the results for transreg, and the previous results is for SAS regression. And let's look at the parameter estimates. Actually, the other ones besides the parameter estimates we're not really interested in, because conjoint analysis, it's a little bit meaningless to look at the other parameters or other analysis variance. It's not what really that we are looking into, and even like the intercept is of not particular meaning in the conjoint analysis. So we're going to look at the estimate for each variable. So that is this part right here. So make, it seems that it has a parameter estimate of 9.6, price is 40.6, miles per gallon is 30.4, and door is 14.9. And the bigger the value that it is for the parameter estimate, it means that it is a more important attribute for the conjoint analysis, and we call that as utility. Okay. So it seems that the price utility is quite high and the make utility is low. Okay, and we probably see the same results for transreg, and yet now you notice that the price is negative 40.6 and make is negative 9.6, and so on for miles per gallon and door. But you notice that except for the direction, that is it is all minus in the transreg, but you probably notice that the value is the same, okay, for regression and transreg. It's just that transreg interpreted as if you are going to have a make of 0, then you're actually going to subtract your utility, and if a price was 0, then you're going to subtract your utility, which means that if you recall, price was 0 was 22,000 and 1 was 18,000. So you actually have less of a utility for 22,000, which makes sense because it's you don't want less of a price to have a less of a utility. Obviously, if you're paying less price, then that's more utility for the consumer. Okay, so we kind of went through like running a simple two-level or full profile conjoint analysis. I know it's not probably the most applicable one, so we'll go into a more of a one that is for more related to the real world, and that is a multi-level full profile conjoint analysis, meaning that you have multi-levels. But in some cases, multi-level doesn't mean that you have all the combinations. So in the previous example, you had all the combinations, but once you go into read in our data, then you probably notice that there is not all the combinations. Okay, let's try to do this first. Okay, what I'm going to do is I'm going to read in a file called smartphone conjoint, and I'm going to read in the data sheet, and I'm also going to read in the conjoint combinations. And let's look at the data first on Excel file here. Okay, so this is the data sheet. Okay, now you have the observation, which is the observation is each person, and they had up to 30 questions that they can answer for a smartphone conjoint. Okay, and what were the conjoint for those 30 questions? So it was as above. Now, you probably noticed that as a brand, you can select Samsung, Apple, or other global brands or local or unknown brands. Okay, and as for screen size, you have 3.5 inch, 4.5 inch, and 5.5 inch. As the third attribute, you have the memory size, which is 32 gig, 64 gig, and 128 gig. And for the camera, you have 8 megapixels or 12 megapixels. And for price, it goes from $299, $399, $499, $599, $699, and $799 and $899 were the price points. Okay, so now these are the attributes, and you probably notice that not all attributes have all the combinations, okay, which is probably a more realistic case than having the full combination, but it's still okay. We can still run the conjoint, and based on these 30 types of attributes on brands, prices, and screen size and memory and so on, based on these 30 attributes, the or 30 combinations of attributes, each consumer is going to give a ranking or a rating, a rating of each of the phones. So that is for this example, the first person gave the first combination a point of 85, which means that if this consumer were to buy an Apple smartphone that is 4.5 inch, 32 gigs, and 8 megapixels at $599, he's going to rate that as 88. Okay. And I know for those people who probably know smartphones, Apple doesn't have a 4.5, they actually have a 4.7 inch. But in order to make a comparison kind of fair, and you don't want to have all the different type of smartphone sizes for the conjoint analysis, but actually in the real case you can make one, but actually in this example we didn't do that. Okay, so now let's go back, and what I'm going to do is I'm going to read in the data, okay, by using proc import. So it seems that I didn't get any error message, so it probably has, oh, it says, oh, I probably need to close it. That's probably why it's causing this error. Okay, so let's go back and import my data. Okay, it seems now it has been read in successfully. Now, what I'm going to do, I'm going to create a column of ratings. Okay, so I'm just going to get the ratings and just make it as a full column. And this is a step that SAS has to make because SAS is more of or less of a matrix type of operation. So I'm going to make this rating as a column. Okay. Now I'm going to have to make a matrix of conjoint descriptions and the attributes. So what I'm going to do is I'm going to get the conjoint data set. I'm only going to keep the 5 parts here: brand, screen size, memory, and camera and price. Okay, so I'm going to do that part, and I'm going to have a combination of this C matrix, not just for once, but 150 times, because 150 was the maximum number of observations that I had. Okay, so I'm going to call that method by using macro and just repeat that 150 times. Okay. Now what I'm going to do is now I'm going to combine these two, okay, which is the combination of each attributes with the ratings on one column. Okay, so if I were to do that, now I'm going to call this data set as smartphone. So if I go to smartphone, what I'm going to have is I'm going to have attributes of each combinations, okay, and I'm going to have its corresponding ratings on it for all of the observations, which were, seems at 4,500, which makes sense because there were 30 combinations of attributes and there were 150 consumers that made the choices. So 150 times 30 is 4,500. Okay, so I'm going to close this and go back to my SAS file. So now what I'm going to do is that I'm going to have a run on a proc transreg. Now I'll probably just use it to later to kind of show you how different it is for multi-levels for transreg or proc reg. But for now I'm going to use proc transreg and see the results. Okay. So if I click this, now you see that I probably have the answer here. Okay. Now you probably noticed that for utility, you have each the utility for certain brands, and you have utility for the screen size, the memory size, and the camera, and for each price points. So let's go by one here. Okay, and you probably remember brand 4 was the last brand. It's the default brand, which is corresponds to local brand here. Okay, let's go and see what that was. Okay, if I open this, so yes, you probably noticed that the local or unknown brand was 4. It seems that that is the one that it was least preferred, and 1 was Apple, and 2 was Samsung, and other global brands were 3. Okay, so going back to the equation here, you probably noticed that Apple is the most preferred by a utility of 22, followed by Samsung of roughly 16, and followed by other global brands like LG, Sony, and so on was 5, and the unknown brands or a local brand is utility of 0. Okay. Now for screen sizes, screen size 1 was, if you recall, that was 3.5 inch, and 2 is 4.5 inch, and the third screen size 5.5 inch, which is the largest one. So it seems that that has the most utility because you can notice that screen size 1 and 2 both have a negative value. Okay, so which means that 5.5 is the most preferred one. But however, you kind of notice that the gap between 1 and 2 is a lot larger than 2 and 3, because 2 and 3 only had a 1.2 difference in terms of preference. But however, if you compare 1 and 2, the gap is roughly around 14. Okay, so people like 4.5 or 5.5, but they seem to have a far less of a preference for 3.5. Okay, now going into the memory size, I think we kind of see a similar pattern. If you recall, memory size 1 was 32 gig, and memory size 2 was 64, and memory size 3 was 128. Seems that there's some preference for 128, but not too much over towards the 64. But however, if you are on a 32 gig, in that case, you do notice a quite a significant difference here. Okay, and looking at the camera, if you remember, camera 1 was 8 megapixels, and camera 2 was 12 megapixels, and obviously 12 megapixels is a little bit more preferred by 2.8. And if you kind of compare the prices, if you remember, price 1 was $299, price 2 was $399, and so on, and all the way up to price 7 was $899. And obviously, the higher you are, the less of a preference that you have. So you probably see a positive value here. So 299 obviously has the highest utility with 23, and the second was 399, which is 13, and kind of goes down. And you kind of notice that there is somewhat of a diminishing return in terms of price increase, which means that there's not much of a big difference in terms of preference going from say 799 to 899. Okay, now that's the utility part, and the next part that you should probably look into is the importance of each of the attributes. Okay, and it seems that this adds up to 100. And price, it seems that it has a importance of 33% roughly, and then followed by brand, which is 32%, and screen size is next, the third important, which is 21%, followed by memory size, which is 10%, and the last one would be camera. So this is something that you could probably look into in terms of looking at the importance of each attribute. And you can kind of see that what the trade-off could be by looking at the utility of each of the attributes levels. Okay, and I'm just going to run a regression on this. And some people kind of just use this to look at the importance of each attribute. So I'm just going to run regression on the same file here. Okay, and now you can probably notice that there's some preference estimates for parameters that you can see. You probably notice that price is obviously going to be negative, which means that the higher you are, then there's the less importance that you're going to look into. But unlike the two-level case, it's really hard to use for what values that you're going to use here. That's probably the reason that we are going to use transreg for multi-level conjoint analysis. Okay, so I hope this example kind of shows you how you can do conjoint analysis on a full profile. You can probably download some of the files on my webpage and probably do it yourself. Okay, all right, thanks.